Welcome to the UpTech Report series on artificial intelligence. I'm Alexander Ferguson. This video is part of our deep dive interviews where we share the wealth of knowledge given by one of our panel of experts. For our second series of deep dive interviews, I sat down with Robbie Allen, CEO of Infinia ML in Durham, North Carolina. Robbie has a degree in engineering and management from MIT and is completing his PhD in computer science at UNC Chapel Hill. He owns 6 patents and has authored 8 books, so he has a great deal of knowledge in this space. I start off by asking Robbie, how has the resurgence of machine learning changed AI overall?
What's happened is that machine learning has been included as a part of some of the other aspects of artificial intelligence, like computer vision, like natural language processing. And so we're seeing sort of a renaissance in many of those fields of artificial intelligence, in large part thanks to machine learning as an underlying technology driving them.
What's the difference between machine learning, deep learning, and reinforcement learning?
So machine learning, at sort of a fundamental definition, is the way I describe it, is automating something and learning patterns with data. So essentially you start off with the data set and it's essentially learning, the software is learning patterns in that data so that when you give it new data in the future, it can make a prediction or it can tell you, how it's similar to what it's seen in the past. And so that's really what machine learning is. Deep learning is a specific type of machine learning that you can think of as just a more complicated version. It allows you to kind of really go at a very deep level, to use the term, to find patterns in a more intricate way than, kind of maybe what we've done in the past. And that's primarily due to the computational resources that are now available, as well as the enhanced sets of data that are available. Now we can apply essentially more processing, more capability at traditional machine learning algorithms so that they can find patterns in more nuanced ways. So reinforcement learning is a way to train an algorithm based on a reward system. So essentially, can you identify a behavior that you think is good? And so what happens is the algorithm will try out lots of different approaches, and once it gets rewarded, it then kind of files that away. Okay, that the path I took to do that was the right path, and so I'm going to keep track of that. And I'm going to try to do more of that versus something that was not a success. With natural language, that's a special case that and really there's 2 main fields within machine learning: natural language and then vision, which is image processing. Those are the 2 main data inputs that you get. There's also tabular or numeric data that you can also work on, but oftentimes you'll hear about natural language processing or computer vision as the 2 main areas. Vision has probably had the biggest advancements to date, and you maybe have heard the most about it, whether it's facial recognition or things of that nature, just because it's a more constrained problem space, right? You're talking about an image, and really you're kind of trying to focus on identifying maybe things in the image. Versus natural language tends to be a little more unbounded, and again, there's multiple languages, there's all sorts of nuances to language that are not present with images, and I think it tends to be a harder place to kind of get the same level of accuracy. And then when you start talking about generating text, that's a whole nother game. And my first company, Automated Insights, that's what they do is automatically generate text, and it's decidedly not machine learning based, at least the text generation piece, because of this probabilistic sort of attribute of machine learning. We can't deliver results that are right 80% of the time because people are so finely tuned to any issues in text. They can easily identify when there's something out of whack, right? An image actually can have a little bit of error built in and people be okay with it. But if your sentence comes out garbled 1 out of 10 times, you're going to know it and you're not going to, appreciate that. And so natural language is a little bit harder case in the machine learning space just because people are very finely tuned to text, and if something's off, you can spot it very instantly, and it doesn't sound very good.
What is natural language processing, and how does it work?
Traditional natural language processing techniques are what are referred to more as brute force techniques. That is, you try to definitively describe all the different parts of speech, for example. And so you'll have these very complicated rules-based systems that, and heuristics that are kind of built in to try to automatically determine all the different parts of speech. But the problem with speech and language is that it's changing all the time. It's a very tricky thing to really kind of define discretely. And so with machine learning, when it came to prominence, what that allowed you to do is actually automatically learn the rules of language versus someone actually having to, define all those by hand. Now you can just throw a lot of data at it and have it try to automatically detect the patterns and detect the rules of speech and the rules of language. Traditionally, you may try to build a natural language processing system off of traditional, voice-based capabilities, but guess what? Everybody says things a little bit differently. I have my own accent. I'm from the southern United States, and you can probably hear that a little bit. And so traditional natural language processing and speech processing techniques would fall apart because, they'd have to be built off of a particular type of speech system. They weren't able to really handle the nuance and the accents that were present. Now with machine learning-based systems, it can be built with initial base model, but it can also learn over time. In fact, Alexa and some of these other systems have capabilities where you can actually talk to it and have it learn your specific ways of speaking, and that just wasn't possible before.
How did you get interested in AI, and specifically machine learning?
It really starts back all the way to the mid-90s when I started working in computer science. And that kind of continued on to my first job, which was at IBM's networking hardware division, and then followed by working at Cisco. And so I've always kind of, in my early part of my career, involved in the sort of networking and hardware space. But even back then, the core of what I did was automate things. And really, the way you could think about what does artificial intelligence really hope to promise is just an enhanced ability to automate. And so I've been, fascinated with abilities to automate things from many years back. And now with artificial intelligence, and I did some of my work at MIT, looking at artificial intelligence in the mid 2000s. Even then, it just still wasn't at a point where you could do it at scale and have the kind of impact that we're seeing today. It's only early 2011 and 12. There was a confluence of things that happened that now makes machine learning a very practical tool to use when you're trying to solve certain business problems. And that's just like I'm a kid in a candy store, because now it opens up all these different things to automate that just weren't possible before.
How do you go about solving these business problems with machine learning?
The initial part is really translating the business problem to a machine learning problem, because it's not always the case that somebody tells you, all right, we have this invoice processing system and it's highly manual and repetitive, and now we want to automate it. Well, that's good, and that's a good frame to start with, but you then have to translate that. Well, what does that entail in terms of a machine learning problem? Like, what are the ways that we're going to apply machine learning to maybe break down that business problem into a series of machine learning problems that we can then ultimately stitch together to deliver a solution? So I'd say the first step is really helping define the business problem in machine learning terms.
This was just a taste. Stay tuned as we share the full deep dive interviews we had with each one of our panel of experts and our upcoming episodes focused on specific topics that will transform the way you think about artificial intelligence. All this on UpTech Report's new series on AI.